Okay, so as I'm waiting for a few people to show up here, just an announcement about homework. Homework must be in a single Word or PDF file. If it's not, I won't grade it. And the reason for that is it's just extra time. Now, you probably think of, well, what's the extra time? Well, most weeks I'm going to have like 180 assignments to grade. And so when I have to go through multiple image files, that just adds to the time where I'm already looking at about 6 hours of grading a week. Minimum, that's going without stop. So I'm going to insist that it be one file. And I'm going to admit a couple here. If it's not in one file, then I'll just make a note, must be in one file. I won't grade it until it's in one file. And I'm just going to start that from the get-go. I've had other semesters where I didn't have so many students, and I took the multiple files and just opened them one at a time. But this semester, I can't do that. It's just a bit too much with all the students I have in all the sections. So, and besides all the grading, I'm doing these lectures and I'm creating quizzes and online tests and all kinds of other things too. So it's getting to where I don't have time to even do everything I need to do. So I'm looking, and I think most of you are here that are going to be here. And it is almost 2 o'clock. I lean in here to look at the laptop. So again, if you've just joined, homework must be in a single Word or PDF file. If you know how to use Cam Scanner to put your homework into a PDF with your phone, that's fine, that works good. But one file per homework. And there's the tutorial that shows how to do this. I'll send it out in an email again, but it's in the content section, how to submit homework. Okay, so let's start here. So we finished that first section, and now we're getting into fractions. Fractions have a numerator and a denominator. The numerator tells you how many pieces. The denominator tells you the piece size, or how many pieces each whole unit is cut up into or divided into. So how many pieces per whole unit. So a fraction like 4/8, that means 4 pieces, and each whole unit is cut up in 8 equal size pieces. So 4/8 of a pie, we cut the pie in 8 pieces and we take 4 of them. Now, if we have 4/5 of a pie, we cut that pie up in 5 equal pieces. Let's see, there's 3, 4, 5. That's not bad. And we take 4 of them. And as you can see, the denominator tells you the piece size. We can't add 4/8 to 4/5 unless we change these to an equal piece size which in this case would be 40, the common denominator. That's why you have to have common denominators when you add fractions. They have to be the same type of pieces. That denominator tells you the type of pieces. And we'll get to adding and subtracting fractions soon enough here. Probably next week, maybe today. Okay, 4/8, that's the same as 1/2. So this shows how we reduce fractions. If we take 4 and divide by 4, we get 1. And if we take 8 and divide by 4, we get 2. So 1/2 is 1/4 as many pieces because the piece sizes are 4 times bigger. So that's how we reduce a fraction. We divide the top and bottom by the same number. And I probably shouldn't even be writing this because this is going to have a transcript. So I can kind of reduce the writing. So 4/8, we divide by 4, divide by 4, we get 1/2. So that's how you reduce a fraction. That's why reducing a fraction works. You're changing the piece size, which means then you change the number of pieces. So see if you can reduce let's do 84 hundredths to lowest terms. And while you're doing that, I'm going to admit a couple of people here. So we're reducing 84 hundredths to lowest terms, people that just joined. And if you got stuck in that waiting room, I don't know if you saw, I sent an email about a procedure on how to log in so you don't get stuck in a waiting room. I'm trying to think of the help person for you as students. I'm not sure if you're having problems with that, what to tell you. This Zoom stuff is as new to me as it is to you. The only thing I've done in Zoom before this is attend some meetings. But if you follow that procedure in the email I sent, you should be able to get in here without getting stuck in a waiting room, which, you know, I have to go and admit you in. If class has already started, then you're kind of waiting for me. So reduce 84 hundredths. Now, the quickest way to do this is to divide top and bottom by the largest possible number. Now, it turns out 4 divides in possibly something bigger than 4. And you don't have to start out by dividing by the largest number. We could divide top and bottom by 2 to give you 42 fiftieths. Then divide the top and bottom by 2 again, 21 25ths. And do it in 2 steps so you don't have to do some long division here to figure this out. If you've got even numbers, you can just cut them in half and reduce it down and then reduce it down. We get to 21 25ths, it won't reduce down anymore. The only thing that divides into 21 is 3 and 7, and the only thing dividing into 25 is 5 and 5 and 5. The divisibility test for 3 is the digits have to add up to something that divides by 3. 2 plus 1 is 3. So that's divisible by 3. That's a nice test to remember. So we've reduced that down. in a couple steps. So let's try another problem. Reduce 3210 over 4320. Large fraction. So try this. Try to reduce this to lowest terms. Oh, and I got rid of that autofocus thing yesterday. So it's not going to keep focusing in and out. And hopefully I've got the color adjusted now where it's a little bit more contrast too. So here, first of all, they both end in 0. They're both divisible by 10. So right away it reduces to 321 over 432. Now, the top is odd, the bottom is even, so we can't just cut them in half. But the test I just told you about, divisibility by 3. 3 plus 2 plus 1 is 6. That divides by 3. 4 plus 3 plus 2 is 9. That divides by 3. You should be able to divide both of those by 3. And we get 107 for the top. For the bottom, let's see, 144. So this one is a little more work because you got to do those divisions. So we get 107 over 144. 107 is not divisible by 2, by 3, by 5. And that's as far as you can go. Okay, so reducing fractions, pretty straightforward. Now, converting a fraction into a decimal without a calculator. To convert 5/8 into a decimal without a calculator, we go back to the fact that 5 over 8 is 5 divided by 8. So divide 5 by 8. And for this class, I am requiring that you be able to do long division of at least a couple small numbers like this. I'm not going to have you be dividing 3-digit numbers by each other or anything like that, anything really horrendous, but just the basic division process. Because not only is it handy to know how to do this, but if you take more algebra classes, this long division, it's called the division algorithm, is something that's used in higher math. You divide polynomials, you're going to use this same process. So the first step in doing this, and I realize some of you haven't even learned this very well, or maybe not at all, is we divide 8 into, we ignore that decimal point except it goes up in our answer, 8 into 50. How many 8s go into 50? Well, 5 times 8 is 40. 6 times 8 is 48. So we divide 50 by 8. Then we get an answer, and then we multiply that answer by 8 to get our 48, then subtract 50 minus 48 is 2. The next step, carry down. The 0. And then you start the process again. 20 divided by 8 goes in there 2 times at the most. 2 times 8 is 16. 20 minus 16 is 4. So we've subtracted. Now carry down the next 0. 8 into 40 goes 5 times. 5 times 8 is 40. Multiply, then we subtract. 0 is our remainder, so we're done. So our answer is 0.625. And what the division algorithm does, it figures out how many groups of 8 go into this big number. 6 times 8, 48. Well, that leaves 200 left. Then we say, well, there's 20 times 8 makes 160 is actually what this is like. Then we find there's a 4 and there's 40 left over. We have to account for those. 5 groups of 8 goes into that. So that's the division algorithm. So let's give you another one to do. Divide. Oh, let's do 3/16 and write as a decimal. So try this one on your own. Divide it out like we did that one just now. So set it up, 3.000, as many zeros as you need. We can add some if needed. Start dividing 16 into 30. First part of your answer goes right after the decimal point. Subtract or multiply that result times 16, put it underneath, subtract, carry down, divide again, 16 into whatever you have down here, put the result up there, multiply, subtract, and carry down. Okay. All right, everybody's in. Okay, so we'll go through this. Some people have this done, maybe some are working on it. 16 into 30, 1/16 goes in there. Not quite 2. 2/16 would be 32. Then we subtract 14, carry down the 0. Now we have to figure out how many 16s go into 140. Oh, let's see. How many? 8 times 16. 48. Okay. I guess 8. Because 128 from 40 is 12. So 8 at the most. 9 of them would be too many. 9 would be 144. So 8 times 16 is 128. Subtract 2 and 1, 12. Carry down the 0. Okay, how many 16s going to 120? Well, we just saw that 8 of them made 128, so that has to be 7. And this one's a little harder because you have the 16. 7 times 16, 42, 7 plus 4, 11. So 112. And actually, I could have figured that out. Just take away 116 from 128. 112. And this seems like it's going on forever, but it does stop pretty quickly here. Carry down that next 0. 16 goes in 5 times. Even into 80. So your answer is 0.01875. So yeah, that one was a little more work. So divide, multiply, subtract, carry down. All right, so here we had a fraction that turned into a nice terminating decimal. Sometimes that's not the case. If we have 2/9, and we write that as a decimal, when we divide out, 9 goes into 20 twice. Carry down, we get twice, and we get the same pattern over and over and over. So 2/9 is the repeating decimal, which we write 0.2 repeating with the repeating bar. So why don't you write 3/11 as a repeating decimal? So divide it out. Divide 3 by 11. Which means you start dividing 30 by 11. Two 11s go in there. Subtract. Get 8, carry down a 0. 7 11s go in to 80, giving you 77. 7 times 11. Subtract. And we get another 30. So you're going to get 2 7, 2 7, 2 7. So 3/11 is the repeating decimal 0.27. Repeating where we put the line over the 2 7 because the 2 7 repeats over and over and over. Okay, and one other situation. So we have terminating decimals like 3/8, 5/8. We have repeating decimals, but then also you might have a decimal that it repeats, but no nice pattern to it. it turns out that all fractions will eventually have a pattern. But sometimes the pattern is quite long and we don't want to write all those digits out. So let's say we want to write 2/7 as a decimal rounded to, oh, let's make it 2 places, 2 decimal places. So we do this division. And we're doing it longhand here because just to learn longhand division. But on a job or something, you just take 2 and divide by 7 on your calculator, and then you'd have to know how to round it. And it's important to know how to turn a fraction into a decimal and a decimal into a fraction, which we'll cover as well. So 20 divided by 7 goes in there twice, making 14. 20 minus 14 is 6. Carry a zero down. Here you have to know your 7s here. 9 times 7 is 63, which is too much, so it has to be 8. 8 times 7, 56. Now subtract. Okay, if we want 2 places and we want to round it correctly, we actually need the 3rd place. And if it's 5 or more, we round up. Okay, when we do the next division, 7 into 40 goes in there 5 times because 7 times 5 is 35. So that's enough to make it round up to 0.29. That's the rounded answer. And oftentimes that's what you're doing with fractions, turning them into rounded off decimals. And how you round them depends on what you're doing. Sometimes you need more accuracy, sometimes you don't. Okay, so we've covered how to turn fractions into decimals. We now need to know how to turn decimals into fractions. More importantly, what does that decimal indicate? I know there's a simple procedure for this. To convert decimals to fractions, count the decimal places, place the decimal part over the correct power of 10. So place the decimal part over the power of 10, where the number of zeros equals the number of places. It's really quite simple if you remember this rule. So for example, 0.01, we have 2 places. So that's going to be 1, the 01, we don't put the O in front of it, but just the 1 over 1 with 2 zeros. Number of places equals number of zeros. So 0.01405 is going to equal 1405 over, okay, we count the number of places after the decimal point. 1, 2, 3, 4, 5. So that 1405 goes over 1 with 1, 2, 3, 4, 5 zeros. 5 places, 5 zeros. And the word name of that would be 1,405 100 thousandths. So let's have you do the following. Convert 0.0128 to a reduced fraction. So try that. Turn it into a fraction, then reduce the fraction. So you put the 128 over a power of 10. And the power of 10 is determined by how many places? 4 places. So we have 4 zeros. Okay, now from there you can reduce it. And here again, you can do it in steps. 64 5 thousandths, cutting 10,000 in half. Then cut 64 in half, 32, and 5,000 in half, 2,500. They're both even numbers, so we can keep going with that. 16 over 12, 50. Cut them in half again. 8 over 625, and that's as far as you can go. Because 8 only divides by 2 and 4 and 8, and none of those divide into 625. So that's the rule to remember. That's kind of an important rule. Turning a decimal into fraction. And what about the following? What if we had this decimal? Convert 1.25 into a fraction. Now in this case, we have that 1 in front. So what we have is 1.25 is 1 plus 0.25. So we're actually not going to have a fraction here. We're going to have a mixed number, which we could write as a fraction if we wanted as well. So it's actually technically it's going to be a mixed number we get. So we have the 1 plus that decimal part. And the decimal part is 25 over 100. And then we can reduce that down. 25 goes into 100 4 times. So it reduces to 1 1/4, or as an improper fraction. 4/4 plus 1/4 makes 5/4. And on a quiz or on a homework assignment or the midterm, if I asked for this, I would accept either of those answers, the mixed number or the improper fraction. So that's how you handle, converting a decimal when you have a number in front of the decimal part. That's your whole number part. Okay, so let's see. Our next topic is percent, which is pretty important. Percent means per 100. So if you have 25%, that's 25 per 100. Or some say percent means hundredths, 25 hundredths, which we can then, of course, reduce to 1/4. And it also equals 0.25, because 0.25 is 25 hundredths. So there's something I call the rule of 2 places for turning a percent into a decimal. You move the decimal point 2 places. The percent is the bigger of the 2 numbers. So this is a rule for turning a decimal into a percent or a percent into a decimal. I probably should have written that. So for converting between decimal and percent. Now, once you turn the percent into a decimal, you can then turn it into a fraction if you want. And if you have a fraction and you want to turn it into a percent, we know how to turn a fraction into a decimal. We divide it out. We can then turn that decimal into the percent by moving the decimal point 2 places. So here you have a way of going back and forth between fraction, decimal, and percent. So, for example, 0.8% equals what decimal? The rule of two places says move that decimal 2 places. And the percent has to be the bigger of the 2 numbers. Now, if we move the decimal point to the right 2 places, we get 80. Well, that can't be correct because the percent has to be the bigger number, not the smaller. So that means this decimal point has to go left. And we have to add a 0. So we get 0.008. Now, once we do that, we could write the 0.008 as a fraction if we wanted. Okay, let's try another. Write 1.234 as a percent. 1.234 is a decimal. Well, we'll use the rule of two places. We move that decimal point two places. If we move it to the left, we get a smaller number. We need the percent to be the bigger number, so we move it to the right. It's always two places. So 1.234 is 123.4%. So let's see. Let's try another one or two. Write 0.012% as a reduced fraction. This is the problem that people get wrong even to the end of the course, and I'm not sure why. Because if you use that rule of two places to get the correct decimal, then you should be able to get the correct reduced fraction using that other rule. I guess it's two rules you have to remember here. So move the decimal point to make it a decimal. Write that decimal as a fraction using the other rule where you count the number of places to give you the number of zeros or the power of 10, then reduce that fraction. So if I move that decimal point 2 to the right, I get 1.2. And that can't be right because the percent has to be bigger, not smaller. So that decimal point is going to have to go 1, 2, 2 to the left, which makes 0.00012. Now you count the places. 1, 2, 3, 4, 5 places. We just put the 12. We don't put the zeros in front of the 12. Over 1 with 5 zeros. So it's 12 100,000ths. Now to reduce that, cut each number in half. 12 over, or 6 over 50,000. And then you can one more time reduce it. 3 over 25,000. You could have done that in one shot by dividing top and bottom by 4 as well. So now you have a way of going back and forth, and I think it's kind of important if you're in some sort of program, you should be able to correctly interpret a percent like this. That's a very small amount. And percents that are bigger than, or decimals that are bigger than 1 mean over 100%, like our last problem over here. So that's kind of important stuff to know. And I had another problem here. Convert 5/7 into a percent rounded to the nearest 10th of a percent. So by hand, without a calculator, turn that into a decimal, then turn it into a percent and round it to the nearest 10th of a percent. So this kind of summarizes a lot of what we've done today. Working with turning fractions into decimals, rounding, turning decimals into percents. But here we're going to be rounding the percent. So we do this division, 7 into 50, 7 times. 7 times 7 is 49. Subtract, get a 1, carry down a 0. 7 into 10, 1 time. Subtract, get 3, carry down a 0. And now we're sort of wondering, how many places am I going to need here? 0.71. If I turned it into a percent now, I just have 71%. So for sure, that's not enough places. We need more. 7 into 30, 4 sevens go in there. 30 minus 28 is 2. We need another 0 to carry down. Okay, now if we stopped with this result, we'd have 71.4%. Well, we don't know whether to round that 4 up or not, so we do the one more division. 7 goes into 20 twice. And we can stop there. And I'll just put dot, dot, dot. But we don't need any of the digits after the 2 because this turns into 71.42%. That gives us enough places to round it to 71.4%. And hopefully you'll get a feel for these percents. 71.4% is close to 70%, which is 7/10, a little less than 3/4. And that's what 5/7 is, a little less than 3/4. Okay, so that's all the topics, and I actually created a review video for this as well that you can view and do problems with that. So I'm just going to start this next section, adding and subtracting fractions. Just going to start it. If we want to add, and I know this is in the notes, but I'm going to put it anyway. 1/3 plus a half. One piece, each pie or each whole unit is cut up in 3 pieces. One piece, each whole unit is cut up in 2 pieces. If we're talking pieces of pie, we got pieces that look like that. And there's no way we can come up with an answer the way it's written. So what we do here is, instead of reducing the fractions, we build the fractions by multiplying the first fraction by 2 and by 2, the second fraction by 3 and by 3. Okay, that gives us 2/6 plus 3/6. That gives us the same piece size. 3 times 2 makes 6. 2 times 3 makes 6. We chose 6 because both 3 and 2 divide into 6. So 2/6 and 3/6. So we have those thirds, but then we're subdividing those thirds. So the pie here has twice as many pieces. So to get the same amount, we have to take twice as many of the pieces. The pie is cut up into more pieces. And likewise, the 1/2, we're making that into 6ths as well. And I have 1/8 there, so I have to redo that. Okay, well, that's not good. Whoop. There we go. There we go. 3/6 and 2/6. Same pieces because they have the same denominator. Now we can add those pieces. They're the same type. That adds up to 5 of those pieces, of the size where each whole unit is cut up into 5 equal pieces. That's the concept for adding and subtracting fractions. So you have to have the same denominator. And let's see if I have a problem here for you. So let's add, see if you can do this with 3/4 plus 1/3. See if you can figure out how to do this. Do this addition. Now, next time I'm going to go through the methods for doing this. there's a few different methods for adding fractions, subtracting fractions. Now, if you sort of go back to this problem we just did, we turned the thirds into sixth, we turned the halves into sixth. We got the 6 by taking 2 by 3. That same thing's going to work here. 3/4. We could subdivide those fourths into 12ths. And that's by taking top and bottom and multiplying by 3. So our new fraction is 9/12. The 1/3 we can subdivide each of those thirds into 4 pieces. And so each third is 4 pieces, so that makes 4/12. So the pieces are smaller, which means we need more of the pieces to make the same amount. Pieces are 4 times smaller, so we need 4 times as many pieces here. Here the pieces are 3 times smaller. We need 3 times as many pieces to make the same amount. 9/12 plus 4/12, and that makes 13 pieces, or 13/12, which equals 1 plus 1/12. Or the way we write this mixed number, 1 and 1/12. So we need the equal size pieces to add or subtract fractions. One method for doing this to get the same denominators, to multiply the denominators together to find a common denominator. That's not always the best method to use. It does work on some fractions. That is the method to use. We'll cover that next time. So I think I'll just end it here, end class here. I have in the content area, before I end it, I want to, there we go, share screen. In your content area, I have review videos at the bottom. And I also created a review video for what we did today. It's right here, converting percent to decimal, or wait. Where is it? I thought I put the review video on here. Oh, maybe not, but that's where it's going to be. Okay. So I'm going to end this meeting. Any questions before I end it? Just unmute and ask any questions you might have. Okay. All right, well then I'm going to end the meeting.